Welcome back to the Deep Dive. Today, we are accelerating straight into a really core challenge, I think, for pretty much every modern developer.
Mm.
AI-assisted software building.
Yeah.
We're going to unpack the reality of what Andrej Karpathy called
Mm.
back in early 2025. Vibe coding.
It's such a perfect term, isn't it? It just captures that feeling like you're sort of vibing with the AI. You throw out a high-level idea, and
Right.
suddenly, bam, there's this massive chunk of code. It looks like it works. The pace is just, well, unprecedented.
And the source material we're diving into today is fantastic because it's not just theory, It's based on this really intensive 9-month journey, actually building 9 different working apps.
9 apps.
Using the big tools, Cursor, Windsurf, Bolt.new, Warp,
Mm.
the main players.
Yeah, this gives us the real scorecard, not just the hype. And the core tension, the thing that kept coming up is this. AI can absolutely squash development time. Months of human work, done in hours sometimes. But how do you actually use that speed without losing quality
Right.
or maintainability? And maybe most importantly, without losing your own human grasp on what the system is actually doing.
Are you still the builder, or are you just watching it happen?
Exactly. Have you become a spectator in your own project?
Okay, so let's try and unpack this ecosystem. The developer testing these tools really categorized them, didn't they?
Yep.
Because the experience was quite different depending on the tool type.
Absolutely. Let's start with what they called the instant satisfaction category. These are the cloud-based builders. Think tools like Bolt.new, Lovable.ai.
Ah, right. This is the wow moment we hear about. The source material talks about using these to prototype really fast. How rich are you? Kind of personal finance app.
Yeah.
I type in a simple prompt and boom, minutes later, there it is. A beautiful UI, responsive,
Yeah.
looks amazing.
They absolutely nail the facade. They're brilliant for that quick concept demo. Show the boss, get some feedback.
But there's a catch.
There's a hard ceiling. The magic just evaporates when real complexity hits. So when the requirements went beyond just a pretty screen, needing sophisticated financial calculations or proper back-end data validation, security considerations, things you need for real software.
Yeah, the important stuff.
These tools just failed. They couldn't build the actual foundation beneath the shiny surface.
Okay, so great for that initial spark, maybe.
Mm-hmm.
But if you need production strength, where do you go? That brings us to the next category, right? The serious development environments.
Exactly. Tools like Cursor and Windsurf, they were highlighted as leaders here. These are less instant build and more integrated partners within your existing workflow.
Partners, okay.
And they showed different strengths. Take Cursor for brownfield development that's working on an existing application.
Right, enhancing something already built versus greenfield, which is starting from scratch.
Precisely. So the developer used Cursor to improve an existing RG-based chatbot. RG is retrieval augmented generation.
Mm-hmm.
Basically, the AI uses specific documents, like your codebase files, for context.
So it's not just guessing based on its general knowledge.
Right. And Cursor was, well, masterful. It kept the style consistent with the existing code, which is huge. And it even integrated advanced stuff like GraphRag that helps the AI understand complex relationships within the code.
Wow, okay, so it's not just spitting out generic Python, it's actually learning and matching the project style. That's pretty sophisticated.
It is. But here's something interesting on the greenfield side, too. The developer admitted, hey, I'm not strong on front-end development.
Okay. Many back-end folks feel that.
Yeah. But Cursor actually guided them through building a pretty polished functional map UI application. They called it My Locations. And it wasn't just dumping code. It was apparently teaching good front-end patterns as it went.
So it's like having a tutor built into your editor.
Sort of, yeah. And then look at Windsurf. Remember those complex financial calculations for the How Rich Are You app? The ones the cloud builders couldn't touch? Windsurf was the tool that could handle it. It showed a deeper grasp of the full stack architecture needed for that kind of data-heavy processing.
Wait, hang on. So even within these serious AI tools, you still might need different ones for different jobs. It's not a single magic bullet.
That's exactly what the experience showed. You pick the right tool for the specific task. Prototyping, maybe Bolt. Enhancing existing complex code, maybe Cursor. Heavy full-stack build, maybe Windsurf.
Okay, that makes sense. Tool specialization. Right, let's shift gears. This is where the speed starts to feel, well, almost dangerous. The acceleration paradox. This came up when using really structured frameworks like GitHub Spec Kit.
Yeah, SpecKit is fascinating. It tries to bring discipline to the process. It forces you through these 4 distinct phases: specify, plan, tasks, and then implementation.
So less vibing, more structured thinking up front.
Kind of. It tries to bypass that ad hoc, just ask anything approach. You have to lay out the specs first.
And the case study was this personal project, ArtMind, a knowledge management system. SpecKit took this high-level idea.
And just exploded it, expanded it into this incredibly detailed specification, including things like document processing, semantic search, really complex features.
Okay, sounds powerful.
And here's the thing, initially it was incredibly educational. The developer said the framework basically forced them to use modern Python tools they hadn't used before. Things like Rough for code linting, just file for automating tasks, Alembic for managing database changes over time.
Oh, wow. Like Alembic for database migrations? That's serious stuff.
Yeah, and Pydantic models for data validation, making sure the data is clean before it hits the system. The AI was integrating all these best practices automatically.
It's like getting a master class in modern development while you're building.
Exactly, that's the upside. But,
Yeah.
and this is the crucial but, this is where the speed becomes a massive liability. The framework was so good at turning a simple spec into hundreds of detailed tasks that it just completely outran the human's ability to follow along, to actually understand.
That's the acceleration paradox right there.
Yeah.
The speed itself creates a problem.
Yeah.
By the time they got to the second iteration of ArtMind, the developer was just drowning. Thousands of lines of perfectly generated best practice code spread across dozens of files. The system was technically brilliant, but in the developer's own words, it became increasingly alien to my understanding.
Wow. Alien. So the tool built this amazing thing, but the builder felt completely disconnected from it.
Yeah.
Did the speed actually make them less capable of managing their own project?
It felt like it. It created this feeling of owning a really complex machine you have no idea how to fix or even properly operate. This sense of being overwhelmed, it really triggered a necessary change in thinking, a shift away from just maximizing generation speed.
Towards prioritizing what? Code ownership, understanding.
Exactly. Ownership and scrutiny, which led them to try a different approach with the ArtMind 4 iteration using Warp Terminal.
Well, okay, how's that different?
Warp integrates AI directly into the command line, the terminal, and its whole philosophy seems to be the opposite of SpecKit's speed. It forces a very deliberate step-by-step workflow. Because it's sequential, right? You run a command, you see the output, the AI suggests the next step perhaps, but you have to consciously execute it. You don't get these huge dumps of code appearing in multiple files at once.
Ah, okay. It slows things down intentionally.
It enforces a pace where you can actually keep up. You're encouraged, almost forced, to understand each little increment before moving on. It felt like a tool designed to keep the developer connected, not just generate lines per minute.
And this personal struggle the developer felt, it seems to mirror what's happening across the industry, doesn't it?
Mm-hmm.
We know adoption is climbing like crazy. What is it, 84% of developers now using AI tools?
84%, massive adoption. But here's the kicker. Trust in the accuracy of that AI code, it's actually decreasing. Stack Overflow's 2025 survey showed it dropped from 33%, trusting it, down to 33% in just 1 year.
Wow, from 43 to 33. So more people are using it, but fewer people trust what it produces.
Exactly. It confirms that feeling of unease. We use it because it's fast, it gets us something. But there's this growing worry about the subtle flaws, the things that aren't quite right.
Which ties into the #1 frustration they found in that survey. Almost half of developers, 45%, said their biggest headache is dealing with AI solutions that are almost right, but not quite.
Yes, that's the nightmare scenario. It looks fine, it passes basic tests maybe, but deep down, there is a subtle logic error or an architectural choice that violates some unspoken rule that's going to bite you 6 months down the line in production.
So how do you combat that? What was the developer's takeaway?
It led to this really pragmatic rule of ownership. Basically, be enthusiastic about AI suggestions. They're great for learning new patterns or libraries, but put on your skeptic's hat. Scrutinize AI-generated code more rigorously than you would code from a trusted human colleague.
More scrutiny than for a human. That's a high bar.
It has to be. Because the AI doesn't truly understand the context or the long-term implications in the same way a human teammate might. You, the developer, have to be able to explain every single line and justify every decision, even if the AI wrote the initial draft.
And that's not just about good code hygiene, right? There are legal implications too, especially for commercial projects.
Oh, absolutely critical. Current copyright law, at least in the US and many other places, is pretty clear. It requires human authorship for intellectual property protection.
Meaning if it's purely AI generated.
It might not be protectable. So if your company wants to own the copyright or IP for the software you're building with AI assistance, you must be able to document substantial human creative input. Your prompts, yes, but also your modifications, your architectural choices, the decisions you made. You need to leave clear human fingerprints all over it.
Okay, so connecting all this back to the big picture. It sounds like the developer's role has to fundamentally shift. You can't just be the person typing the code anymore.
Not primarily, no. The analogy that emerged is the human needs to become the navigator. You're setting the direction, making the crucial architectural calls, maintaining that strategic overview.
And the AI.
The AI is the driver. It's executing the specific maneuvers, implementing the solutions, but under your explicit guidance. That's the only sustainable way to keep control and ensure quality.
So how do you be a good navigator? You can't just shout vague directions.
No, you have to provide really rich contextual grounding. The developer learned this the hard way. If they felt they were losing the thread, if the AI started generating stuff that didn't quite make sense, they had to be disciplined enough to just stop, terminate that branch of AI work, and restart, this time feeding the AI much more explicit context-relevant code snippets from elsewhere in the project, clear statements about architectural constraints or patterns to follow.
So constantly course correcting. The rule became, do not let the AI run ahead of me for too long.
That's the key. If you lose understanding, you stop, you recontextualize, you restart that specific part. Maintain control.
But the speed is still valuable, right? Where does it really shine?
Oh, absolutely. For rapid prototyping, for building proof of concepts, it's game-changing. The source mentioned building a vulnerability detection demo. Normally, that's like a month of focused work for a small team.
Yeah, easily.
Using Windsurf, they got a working demo built in one focused hour.
1 hour versus 1 month. Okay, that's
Yeah.
transformative for certain tasks.
Yeah.
Rapid validation.
Huge. But that same acceleration becomes a problem in large, complex, long-lived enterprise systems, doesn't it? Just letting AI generate code based on generic patterns, even good ones, is going to inevitably introduce technical debt because it won't perfectly match your organization's specific standards or architecture.
Right, every company has its own way of doing things, its own legacy systems to integrate with.
Exactly. So this creates a new, crucial job for software architects. It's not just about designing the system blueprint anymore. It's about, and I'm quoting here, encoding the standards and patterns into the various SWE agentic prompts or prompt frameworks themselves.
You have to teach the AI how your company builds software.
Precisely. You're building the guardrails, the custom instructions, so the AI driver stays on the company road.
So, reflecting on this whole 9-month, 9-app journey, what's the big takeaway?
I think it makes it crystal clear. The best AI tools, the most sophisticated ones, they don't replace human judgment, they amplify it. They are force multipliers, but only for the builder who remains engaged, critical, and in control.
They enhance judgment, creativity, oversight.
Yeah.
They don't substitute for it.
It really solidifies that personal manifesto that emerged from the experience. Never, ever let the AI run ahead of your understanding. The most critical skill now is the discipline to stop, to question, to provide better context, and to constantly learn alongside the AI. Foster that adaptability.
Okay, so that's the challenge for you, the listener, as you navigate this world. We know 84% of developers are already using these tools. So here's something to think about. Given that risk, we talked about the subtle errors, the architectural drift, the code that's almost right, what's the one key component in your typical project? Maybe it's security logic, maybe it's database migrations, maybe it's core state management. What's the one piece that you, as the human builder, should never fully delegate to an AI agent?
Where does that human wisdom, that deep contextual understanding absolutely have to remain embedded to prevent disaster down the line? What's the part you personally guarantee?
Something to consider. We'll catch you on the next deep dive.